Hi, uh, welcome to another code snippet discussion. So today we have an interesting code snippet where we have a lot of concepts that covers up within this code snippet. Mainly, the most important part that we are going to discuss on this code snippet is the static method usage and the relationship between the child class and the base class, and how we are going to inherit the static method and how we are going to invoke the static method, in what are the variants we can able to call the static method. So all these are the discussions that are relevant to this particular code snippet. So let's straight away get into our discussion today. Okay, so let's bring up our IDE and let's go ahead and create a class named test phone, and it's test phones, and I'm going to add on with main method. We get a base template here. From here, let's go ahead and start creating the respective classes as per the code snippet. Okay, so the first class that we have here is the phone class. So we have a phone class, and we have the smartphone class, right? So right now we have two classes. One is the phone class, another one is smartphone. So why we have two class? So from this we can understand somewhere the relationship is going to exist between these two classes. So firstly, let's look out from the phone class. Inside the phone class, I'm going to add a method called static void call method. The identifier for the method is call, and it returns void, means it doesn't return anything. And the most important keyword that you have to notice here is static keyword. Okay, so inside this, let's go ahead and just put up a sysout statement, and here we are going to carry a statement called call phone. Okay, great. So now in class smartphone, okay, we are going to use extends keyword, and we are going to extend the class called phone. So this is the way we extend a class, using the extends keyword called extends keyword, and the name of the class is phone. So it's a single inheritance standard, and Java supports only single inheritance. And if you see here, the phone is a base class. Okay, it's a base class, and smartphone is a child class. But technically, from the smartphone perspective, this phone class is a base class. But as we already knew, the phone class is not a base class, it's a child class again, because the phone class is implicitly extending the object class. This we have discussed in our earlier code snippet discussion. The rootmost class in Java is object, and it's a predefined class, and it carries some set of public methods in it. So that's how it is happening. So phone class is extending object, still the phone is acted as a child class. Even though we don't see any extends keyword usage here, it's still there applicable for extending the object class. Okay, so phone is still a child class, but from the smartphone perspective, we consider the phone to be acted as a base class, or to be more precise, we can call it as a parent class. Okay, phone class is going to be a parent class for smartphone class. Okay, so smartphone becomes an child class. And what we have done according to the code snippet here inside the smartphone is we are trying to create another method here, which is of the same signature of what we have in the phone class. So static void call, and inside this we are going to use a sysout, and we are going to say it's call smartphone, right? So this is what we have as per the code snippet that we have seen in our image. So right now the signature of both the methods seems to be same, right? So what does it mean? Does it mean, are we overriding the static method? Are we overriding the static method? No, actually we are not overriding the static method. We'll come into that point shortly. But right now you just understand we have the same signature of the method call in phone is also seen in smartphone. The same signature is followed. Static, void, call. The method name is also same. The signature is also same. Okay, I'm not talking about overloading. Okay, I'm only focused on overriding here. Okay, overriding. This is something very much important to notice. Okay, overriding, not overloading. What we mean by overriding? The base class method. Base class method is rewritten in child class. Okay, we are trying to replicate the same method to be rewritten again in child class. So that way we call it as overriding, right? So now the main question that comes in here is, are we overriding the static method here? According to this code snippet, straightforwardly we used to say, hey, it's a overridden method. But the noticeable point is we have a static keyword here. So that's where it's bugging us whether this is an overridden method or not. We'll get into the answer for this question shortly. So as per the code snippet, let's go straight into the main method. I'm going to create a reference variable for phone class, which is going to be called as phone equals new phone of, right? And the second line of reference variable declaration is also going to be on phone. The reference variable is for phone and the variable name is smartphone equals new phone of. So we have to stay attentive here because the reference variables are phone and smartphone, but the instance that it is carrying is I'm sorry, here I have to give an instance for smartphone. I made a typo here. So it's a smartphone. Okay, notice there's a slight confusion arises here because this is the tricky part of this code snippet. The instance what you have here is phone and the instance what you have here is smartphone. So this is the base class and this is a child class. We have the respective instance, but the noticeable point here is both reference variables are pointed to the phone class, right? So now according to this point of view, how this compiler and the runtime interpretation is going to take. So is there any compilation error? No, because the base class can still carry the instance of the child class. Okay, because it becomes polymorphic. Here we take it to an extent of polymorphic approach. So what do we mean by polymorphic approach? One entity can be acted as multiple entities, right? So the phone reference variable can be acted as phone and as well as it can be acted as smartphone also, right? So that's what the key point here. So this snippet of code is referring both the reference variables are referring to the type called phone, but it's carrying their respective instances. Okay, so compiler doesn't say anything. Let's go ahead and say phone object dot call. Okay, and smartphone dot call. Okay, fine. So one thing that we have to observe here is we are actually calling this is something which we should not follow it as a standard. This is an invalid standard because we should not call the static method on top of an instance. It should be called only on top of the class name, because static methods are not bounded to instance, they are bounded to the class names. So the class name smartphone and phone are the class names, and you need to call the call method respectively with the class names only. Okay, but as per the code snippet, they are calling it through reference, and that's why there's a warning occurs. If I hover the cursor on top of the warning, you will notice that the static method call from the type phone should be accessed in a static way, and that's not happening here, right? Because we are trying to create an instance and call the static method through the instance. So instance can be used more specifically to call instance methods. You create an instance to call the instance method, but not your static method. But that's what we are doing here. And moreover, the type of those reference are all pointed to the phone itself. So let's see what's the output of this program. This is what we had in our code snippet. So this is a tricky part here. So our observation here states that, hey, this is a phone instance. So it should go and call the phone class instance, correct? So that's our understanding. So it will go to the phone class instance and call the call method and say call phone. And the next is we still have a phone variable. The reference variable is of type phone, but it is carrying an instance of smartphone. We tend to give more weightage to the instance. We give more weightage to the instance. So when we are giving more weightage to the instance, we think that this is anyways pointed to a smartphone instance. So this smartphone variable will only go to the smartphone and invoke the call method, call smartphone, right? So is that what is going to happen? We need to see that. Wait and see. Here it's smartphone. Okay, there's a typo. Okay, so let's go ahead and see how the outcome is going to be. With that, we will have more further researching. So right now, both the output is saying call phone. Call phone. Why it is saying call phone? Because even though we have an instance of smartphone, okay, the variable is phone variable, okay. So since the variable reference is pointed to the phone, the smartphone variable is not taken to be a consideration for an instance, rather it is taken to be a consideration for the class. So according to this type of reference variable, this is giving a priority only to the phone class and not to the smartphone instance, because the method is not an instance method. It's a static method. Since it's a static method, okay, there is no way that we can think of applying a polymorphism here. Okay, so phone reference variables which are pointed to the phone class will always reflect it to a phone only when you're calling it on top of the static method. Okay, the instance doesn't matter is what I want to conclude here. Instance doesn't matter when you are going to call the smartphone. But if you look at this, let's say for example I have a smartphone here. Okay, if it's going to be a smartphone class, and your output will be respectively, because it is again not reflected to the instance. Okay, at the runtime it's giving more priority to the type of the class, because the static methods are dependent on the class itself. Now you get the respective output. But here again, it's not a good practice. It's not a good practice to create an instance and call the static method. In this perspective, we can straight away use the class name itself, right? So anyways, it's not going to consider the instance at the runtime in order to invoke the static method. It's going to depend only on the type of the variable. The variable reference variable type is smartphone, so it will go to the smartphone and call. But there is no point in having an instance. So initially we had a phone. Okay, at that time it's not acting polymorphically. Of course, it is not going to act polymorphically because technically speaking, this is not overridden. It's not overridden. So what happens? It has a separate method in the smartphone called call. So this method is not getting overridden into the smartphone when you replicate the same method from the base class to the child class when the methods are marked as static. Static methods are not eligible for overriding. Okay, not eligible for overriding. This is a very important point. Static methods are not eligible for overriding. Instance methods are eligible for overriding. Instance method means a method which is declared without the keyword of static inside a class. Those methods are called as instance method. Instance methods are eligible for overriding inside the child class, but you cannot override a static method. Since it's not overridden, it doesn't make to be polymorphic calls. So this approach is not advisable. Never create an instance to call a static method. because in this perspective, of course, we will not get our desired output. It's going to print only call phone twice. Okay, even though we have a reference of a smartphone, the static methods will give the priority to the type in which the reference are coming from, not to the instance. That's the reason the output is call phone. So instead of having the explicitly creating an instance out of it to call a static method, we can just use a class name. That will be more sufficient, right? So why we need to go ahead and use the instance? Not required. They are not instance bound. The static methods are not instance bound, they are class bound. Static variables and static methods both are bounded to class itself. That's why we call it as a class variable and class methods. So you can call those static members using the class name itself. Never go for creating an instance. It's not a good practice to have a instance to call a static method. So according to this, now the output will be more logical. So there will be no confusions as such. So here if you see call phone and call smartphone happens because we call those static methods on top of the respective class names. And more interestingly, if you notice, the warning is disappeared. Okay, the warning is disappeared. Why it got disappeared? Because we are calling the static method in a static way. Call the static method in a static way. Call the static method in a static way. Okay, in a static way. This is very important. So how do we call a static method in a static way? By using only the class names, but not through instance. In this case, obviously we will get confused because we only focus on the instance and thinking that anyways it's overridden, so that it is going to call the smartphone class method. No, it's not. It's not going to call the smartphone class method at this point of time because the variable is depending on the ref type. Which type it is depending? It is depending on the phone type. So static methods will be called from the phone class instead of smartphone. So according to the code snippet, the output is call phone and call phone twice. But when we manipulate it in a more standard way, then we will be able to get the output of call phone and call smartphone. Okay, so I guess this makes it more applicable to understand. So the points to be noted here is static methods are not overridden. Static methods are not getting overridden. They will have a separate copy in their respective classes, and there's no point for creating an instance in order to call a static method. You can call the static methods using the class name itself because they are bounded to the class, not to an instance. So I guess I've given a more comprehensive explanations for this. So if in case you still have some queries, please post your queries on the comments. I'll try to respond to those comments at my best. Okay, so thank you so much. We'll catch up in another interesting code snippet. So until then, have a great day. Bye.